Good evening. Today we will discuss regarding the basics of non-destructive test. In today's class, we will discuss regarding the definition of NDT, different type of NDT applicable in industry, their basic principle, advantages, disadvantages, and the industry where we are using non-destructive testing for our inspection purposes. Non-destructive testing, generally it is the inspection methodology to identify the internal discontinuity or anomalies of your inspection part without destroying it. That means without doing any harm into your inspection part, we can able to determine the integrity of the material or the component or the structure, and as well as quantitatively we can measure the characteristics of an inspection part. That is the basic fundamental of non-destructive test. So non-destructive test or NDT, we can be divided into the two categories. One is surface NDT, like visual inspection, liquid penetrant testing, magnetic particle testing. By the application of surface NDT, we can able to identify those defects which are into the surface or up to the certain depth of surface, that is known as the subsurface defects. So surface and subsurface defect can be identified with the most sensitive way when we are applying the surface NDT. In the similar way, volumetric NDT like radiography, ultrasonic, they are eddy current testing, they all we are using to identify the internal integrity of your inspection part. It may be the welded part, casting, forging, or the assembled part, and the ability to identify all kind of defects associated into its volume. So that's why it is known as the volumetric inspection. Any engineering specification or the code always suggested for the inspection of a particular component by the combination of one surface NDT and another volumetric NDT. So in broad way, NDT or non-destructive test, we are utilized into our inspection tools in different industry like that of refinery, petrochemicals, cement, power, each and everywhere in construction process and fabrication or manufacturing plants. To the basic the requirement of NDT is to identify the flaw or evaluate or detect the flaw into your inspection part. It also able to identify the leak, the cause of leak, its location, dimensional measurements that also done by the NDT, structural and as well as microstructural characterization of your inspection part, that also we can able to be able to identify by the application of NDT. It can able to estimate the mechanical and physical properties of your inspection part. In some cases, stress or strain relationship of your inspection component or material, that means the dynamic response due to the strain or stress, that can be also identified by the applications of non-destructive testing method, particularly in vibration analysis or in acoustic emission testing. And material sorting or grouping of material or identification of chemical composition, for example for the PMI, positive material identification test, we can able to identify that one. So in generally NDT and non-destructive testing, we are using in different industries in different stage of inspection, like that of inspection into the raw product, like that of forging, casting or extrusion, inspection following the secondary processing, like that of machining, welding, grinding, heat treating or plating, and as well as into the in-service damage or inspection that may be the cause of cracking, corrosion, erosion, wear or the damage due to the heat. So the purpose of NDT is to development of the product. It will able to screen or sorting the incoming material. It can able to monitor, improve and control the manufacturing process. It also able to verify the proper processing, such as the heat treatment, verify the proper assembly, and it also able to inspect into the in-service damage. Particularly in the wider sense of industry, particularly if we are talking about the inspection of the weld, then the associated defect into the weld, like that of a lack of penetration, lack of fusion, porosity, slag inclusion, root or crown undercut, mismatch, inadequate weld reinforcement, excessive weld reinforcement, cracks, spatter, arc strike, tungsten inclusion, so whiskers. This kind of weld defect can be identified by the application of suitable NDT. Similar way, casting defects like the filling related defect of blowholes, sand burning, sand inclusion, misrun, gas porosity, due to the shape related issues into the casting, like that of mismatch, misrun, distortion, air flash, thermal problem due to the casting formation, like that of crack, air tears, dendritic, filamentary, spongy appearances, sink mark, shrinkages or cavities. That kind of defect can be identified by the proper application of NDT. And defects by the appearances, like that of metallic projection, cavities, discontinuity, incomplete casting, rat rails, that all can be identified by the applications of NDT. So in generally, in case of forging, like that of unfilled section, cold shot, scale pit, die pit, improper gain flow, these are the type of defect normally associated with the forging, and that can be identified by the proper application of non-destructive testing method. And during the parent material inspection, surface irregularities, spatters, notch, surface roughness, porosity, metallic or non-metallic inclusion, lamination, hydrogen, if the hydrogen content is very high, due to that if the hydrogen embrittlement is there, that can be identified according to the selection of proper NDT. So for the identification of the particular type of defect in your inspection part, the selection of NDT is mostly important, because all the defect in your inspection part have the different probability of detection for the determination by a particular non-destructive test. Suppose we are inspecting a job part of weld, and there if we are considering 5 defects, like that of porosity, lack of fusion, sidewall fusion, crack in longitudinal direction, crack into the transverse direction, slag inclusions, incomplete penetration. And if the same weld, if we are going to inspect by the radiographic inspection, the defects which are associated into a particular plane, that of lack of fusion or the crack into the transverse direction, the probability of detection for the determination of these two type of defect by the radiography is very less, because the radiation beam is exactly not perpendicular for the determination of those defects. But if we are considering the ultrasonic inspection, then those defects, like that of transverse crack or lack of sidewall fusion, that's are perpendicular with our ultrasonic beam, because we can able to interpret the ultrasonic beam, that is, we can able to produce the sound beam and transmitted to the material inspection of material in a definite angle, such that those defects, that is transverse crack into the weld propagation or the lack of sidewall fusion, which are particularly originated in a definite plane, that can be perpendicular bit to the ultrasonic beam, and there is a maximum probability that you can able to identify those defects. In the similar way, suppose one pinhole is there or one surface crack is there into the weld or your inspection part, so there is a less probability, that is probability of detection is very less if we are considering the volumetric inspection like that of radiography or ultrasonic. But if we are going for the visual or penetrant test or magnetic particle test, if it is ferromagnetic in nature, then it is very easy to identify those crack which are into the open to surface or in a very minute dimension. So selection of NDT is a very mandatory process, and it's a very vital process, the which NDT we will be able to select such that our expected defects can be identified in a very high rate of probability. So first of all, our industries has a different type of non-destructive testing method like that of visual inspection, liquid penetrant, magnetic particle, radiography, ultrasonic, eddy current, leak test. Along with that, some special applications like that of acoustic emission, vibration analysis. So a lot of non-destructive testing is there into the industry. But basically, whatever our industrial requirement is there, the basic 5 process, that is visual inspection, liquid penetrant, magnetic, ultrasonic and radiography, by that almost 90% of the industrial requirement has normally fulfilled. So first of all, visual inspection is nothing, it is the inspection of your material by a experienced inspector. And the experience in the sense, the inspector should have a vision acuity in a correct way, and second thing, he has a good knowledge regarding your inspection part, that means the fabrication part, its associated defects and nature of defect, how it will be appeared. So the experience for that particular industry is very important. In visual inspection, we are carried out in the 2-way, direct visual inspection or indirect visual inspection. Direct visual inspection is carried out by the inspector itself, and it's a direct view of your inspection part. When we are carried out the direct visual inspection, definitely the acuity of the eye of the inspector is most important, and along with that the light intensity of your inspection part should be minimum in the level of 1000 lux. The resolution of the visual inspection about the human beings or the inspector is maximum up to the 1 mm, and the distance between the detector, that is the eye, and your inspection part should not be more than 24 inches, and the angle of interaction with your inspection surface, that should be at least 30 degree with the inspection surface. Same that of the direct visual inspection, where the inspector can able to inspect the inspection part in front of it by the naked eye or by using some some aids or something. If the inspector is not able to reach into your inspection surfaces, so he can able to inspect your inspection part in an indirect way of inspection, that is known as indirect visual inspection. In that sense, we are using some kind of instruments like that of fibroscope, boroscope, or robotic rollers, such that the accessibility of that particular area we can able by the imaging process, and it can be identified by sitting in a particular location, and we can visually inspect it. But the visual inspection has some limitation, that the defects which has a dimension of at least 1 mm, that can be identified in a most prominent way. If the defect dimension is less than 1 mm, definitely the process sensitivity will be less. So for that particular purposes, we are using the second non-destructive testing method, that is known as liquid penetrant testing, which is much more sensitive compared to the visual inspection. In penetrant testing, we are using three type of chemicals: cleaner, penetrant, and developer. Different type of penetrant, different type of developer combination is there when we will carry out the second session for your training. Particularly for the penetrant test, we will discuss all kind of penetrant and along with that all kind of developers in that sense. So normally in your inspection part, if any defect which are into the surface and which is open to the surface, that can be inspected by the method of penetrant testing. In that scenarios, we are using the cleaner or solvent or cleaner, and first of all we will clean our inspection surfaces, then we are applying the penetrant. We are wait for some time, that is known as penetration dwell time. After the penetration dwell time, what will happen? The penetrant will be entrapped into the cavities if any discontinuity is there, and after certain time period we will clean up the excess penetrant from the surface, and then we are applying the developer. The purpose of developer is nothing, it will blot the penetrant which will be entrapped into the defects, and after the development time, when the developer will be dried, it will absorb or blotted the entrapped penetrant, and the bleed outs of the penetrant can be identified in a slightly magnified way, and we are inspecting the part by the white image contrast with respect to the red color of the penetrant. Basically, if it's a visible dye we are using, then it is a red in color. So in a white background, a red indication will be there, and it will be much more brilliant and much more prominent, magnified, and we can able to identify the defects. So third NDT method we are using in the industry, that is on magnetic particle inspection, but it's had limitation that the material which can be ferromagnetic in nature, that means the material can be magnetized in a strong way. That means if the material has been magnetized and it can able to produce a magnetic field which has a maximum intensity, when that material will be magnetized, a magnetic line of force will be generated, magnetic lines will be generated, and if any defect is there into your inspection part, there will be the leakage of that magnetic flux, and that leaked area has the maximum magnetic affinity. So when we will apply the ferromagnetic particles from the external sources, then that applied ferromagnetic powder that will be colored for the contrast formation, and that will be attracted from that particular leakage area and give you the indication of the defect or anomalies. Fourth non-destructive test that we are using in industry, that is a radiographic inspection, oldest non-destructive test, where we are using the ionizing radiation, and that radiation is penetrated throughout the material, and the degree of penetration depends upon the density of the material itself. So when the inspection part has the different dense material, the degree of attenuation will be changes, and according to the density of the material, the variation into the transmission ratio of the radiation will be there, and the radiation that will be transmitted throughout the material, that will be making some image into the photographic film, and that image will be formed in the form of some deposition of the silver ion to metallic silver, that will produce some grayscale image. So black and white image into the photographic film will be generated. After the processing of the film, we can able to identify the discontinuity of the material in the form of some white and black grayscale image into the photographic film. It's a permanent image, and that permanent image can be stored for your interpretation to identify any kind of voids is there. So basically the differential absorption, that is the basic principle in radiographic inspection. And fifth method that is mostly applicable into the present days without any hazards, radiation hazards, that is ultrasonic inspection, where we are using the piezoelectric material to produce the ultrasounds with a specific frequency, resonant frequency, and when the sound will be traveled through our inspection part, what will happen? There will be the transmission and reflection of sound from the different surface due to the variation in their acoustical behavior. So whenever the acoustical barrier is there, there will be some kind of reflection and transmission will be there, and that reflected energy, which is basically it's a sound energy, and that sound energy will be converted to the electrical signal by that piezoelectric material, and that electrical signal we will be able to see in a CRT, a cathode ray tube, which is basically known as ultrasonic machine, in the format of your sound traveling path with respect to amplitude of the returned sound. That is the signal that we will get in the form of some amplitude of the return signal. So that amplitude, that's echo versus the traveling path, from that analysis we can able to identify from where the echo is coming, and the nature of echo, location of the echo will be able to identify regarding the discontinuities present into your inspection part. That is the basic fundamental of your ultrasonic inspection that we are widely using into the industry. And nowadays next non-destructive testing method, which is basically most important now for your tube inspection, particularly in power generation plant and heating elements like that of conduction heating or in heat exchanger. So eddy current testing is a most popular for particularly thin tubing, particularly well suited for detecting the surface crack, but also can also used to make the electrical conductivity and to identify the coating thickness measurements also. So eddy current is widely using now for the identification of lower diameter and lower thickness tubing, particularly in the power generation plant or into the heat exchanger industry. Whatever the NDT will be selected, that is most important according to the POD, probability of detection, to identify that particular defect. You can able to follow the table number A110 according to the ASME section 5 article 1, which will be considered as a imperfection versus type of NDE method. If you are following this table, it will give you some general guidelines that according to the imperfection of that particular type of product form, say suppose service induced imperfection like the abrasive wear, baffle wear, show the type of defect, and according to that which NDT can be able to identify in a most prominent way or not. Show the selection of non-destructive testing method to identify that particular type of defect into your inspection part. That will be most important, and that we can be able to whatever we can say, that the selection of non-destructive testing method is most important for the determination of defect in a higher probability of detection way. So in that scenario we can able to follow the table number A110 according to ASME section 5 article 1, which is imperfection versus type of NDT method. Thank you. That is the today's session regarding the basic introduction of NDT. Into our following classes you can follow for the detailed discussion of penetrant test, magnetic particle test, radiography, ultrasonic and eddy currents. Thank you.